Good afternoon, I'm Herbert Gerard M. Hinay, and I'm going to present to you the procedure on how to get the avoidance course using maneuvering board. So, first, according to the problem, our ship's course is 0 to 0 degrees with the speed of 16 knots. So, plot the given ship's course in our maneuvering board, align it to the center, and make a line like this. And then put an arrow here. Next is plot the first bearing observation at 050 degrees. Range is 9.3 miles at 0912 hours and label it as O. Next is plot the second bearing observation. 050 degrees, range is 8.2 miles at 0915 hours. Next is plot the third bearing observation. 050 degrees, range is 7.1 miles at 0918 hours and label it as A. Next is we are going to measure the relative distance of first and third bearing, which is O to A. Para ma-measure mo to ay gagamit tayo ng compass divider. So, measure natin. And then ilagay natin dito sa scale para malaman natin kung ano yung sukat niya. So, as you can see, ang sukat niya is 2.2 miles or 2.2 nautical miles. So next is we are going to get the relative speed from O to A. So the formula is distance from O to A is O to A times plotting time interval over 60. So the distance from O to A is 2.2 times the plotting time interval, which is 6 minutes over 60 equals, the answer would be 0.22. Now gagawin po nating whole number, so magiging na lang siya, magiging 22. So 22 is the relative speed from O to A, 22 knots. Next is we are going to connect these three plotted position up to the center of our maneuvering board, like this. Put a line and then label this as RML para naman malaman natin yung relative course. Is yung line na to is guhitan lang natin kung ano yung tinuturo ng arrow, which is 230 degrees. Yung CPA naman natin is 0 kasi yung RML natin is lumagpas sa gitna and we are on a collision. Next is place your ruler on your ship's course and bring it to the first observation, label as O. So we will and after this you will make a line and label as W. Then next is we are going to get the distance from O to W. To get the distance, we use the formula of speed times plotting time interval over 60. So our speed is 16 knots times the plotting time interval 6 minutes over 60 equals 1.6. so the answer to this is 1.6 nautical miles. The next is we are going to connect the third bearing observation A to the W. So you will connect this, then bring your triangle to the center so we can get the true course. So our true course is 271 degrees. So after this, we will going to get the true speed of the target. From W to A, measure the distance using compass divider and bring it to the scale. So we will measure the W to A. So as you can see, the measure is 1.2 nautical miles. Then using this formula, we can now take the speed. So the formula is distance times 60 times the plotting time interval. So the distance is 1.2, then the times 60, then over, so 1.2 times 60 over the plotting time interval, which is 6 minutes, so equals 12 knots. So the speed of the true target is 12 knots. So the problem is at 09 to 21 hours, we will execute a collision avoidance in according to regulation by changing course to pass the contact at the CPA. So next is we are going to plot the execution point. To get the execution point, get the interval of the plotted position and place it next to a plotting interval. So first you will place your divider here and then place it to the third bearing observation, which is A, and then from 18 to 21 is 3 minutes, so measure the distance traveled by the echo in 3 minutes. They are one bearing only, so measure 1.1 nautical miles. So this 09 to 1 hours is your point of execution and label it with MX. Is if the target is in the execution point, we need to act and change our course into our starboard side. So next is we are going to draw a circle with a range of 2 miles in the middle of our maneuvering board. So we will measure 2 miles in our scale and then place it to the middle and then draw a circle. So this is the circle. Then next is we draw a line from the MX. We draw a line from the MX and place it on the 2 miles on the starboard side of the target. So we will draw a line here on the top of the circle on the starboard side. And this will be labeled as NRML. So next is we are going to get the NCPA. So in order for us to get the NCPA, we will measure 90 degrees from the intersection of our NRML and NCPA. So we will place the triangle here and bring it to the center of this maneuvering board. So our NCPA is 339 degrees. Next is we need to find the avoidance course. So in order to get that, we will place our triangle here in our NRML and bring it to this third bearing observation A. So just like this, and then you will bring it to the A. And then make a line. Next is we will use our compass divider and place it on the W pointing to O, W pointing to O, and make an arc. So make an arc until it intersects to the line we place on A, and label this as O1. After getting the O1, now you will connect the W to the O1. After connecting these two, we will bring this line to the center of our maneuvering board in order for us to get the avoidance course. So place your triangle here and move it to the center of this maneuvering board. So our avoidance course is 0.52 degrees. And that's all. Thank you. So our avoidance course is 0.52 degrees. And that's all. Thank you.